So that was a really amazing and super dense panel. And now we are back, and we will have our next speaker soon on our online stage. And our next speaker will share with us some applications of machine learning and procedural layouts applied on spatial computing. So I'm happy to introduce Agatha Yu from Adobe. She's a senior design manager for 3D and mixed reality. Welcome, Agatha.
Thank you so much for the introduction. Today I'm actually here to share with you guys about my thoughts so far about designing spatial computing with procedural layouts and machine learning behaviors. And before I jump in today, I would love to kind of introduce myself a little bit and let you know who I am. So my name is Agatha, and this is my Twitter/Instagram handle if you want to check out my work. I'm currently a senior design manager with Adobe, focusing on 3D and mixed reality. And prior to coming back to Adobe, I was actually at Valve, where I worked on Half-Life VR, as well as I was also the design lead for Oculus Rift. So I worked a lot with touch controllers, as well as different VR form factors and things like that. So, throughout my journey of kind of creating these kind of immersive experiences, what I learned is kind of 3 core lessons and takeaways. And so today I'll be sharing with you about that. So number 1 is to talk about actually the background and the context of what is changing about computing in general and why it actually really matters now, the fact that machine can integrate a lot more of the human context into the way that it processes information. Second of all is to kind of think a lot about what does that mean? Like the fact that we now have more human context and machines can digest a lot more of these kind of sensory experiences. In a way, I think the expectations for humans in general is that if we give away information, we expect to have kind of interesting outcome as we give more. And so the question here is, how can we kind of match the user's expectation and not solely rely on static kind of assets and experiences that we're very used to in web pages as well as mobile applications. So this is whole idea of what does it mean to kind of manage and to be able to accommodate the growing possibility space of experiences. And lastly, this is kind of something that I kind of have been chewing on for quite a while, especially right now as I think about proceduralism and machine learning, is actually how do we deal with the problem of the curse of dimensionality? This is a very specific problem to deal with when you have a data set with a very large sets of parameters. And the question here is, what is the role of design when it comes to dealing with kind of the ability to, the fact that computers now can generate a lot of different kind of outcomes and solution, and how can design help humans to navigate through those to select the best and the most useful outcome that is meaningful to them. So here are the 3 topics that I'm going to talk about today, and let's jump right in. So, if we look back at the history of computing, starting with the command line interface, we have the keyboard that allows the programmers to directly enter data, execute programs, view the result, and then make any needed correction. And all of that is without the need of those clunky key punch kind of machines in the past and human operators. So, which is great. It gave power to a very small set of people that is well practiced in shaping thoughts into these serialized string of key presses. It's still very abstract, so that kind of tool is actually very constrained to a very small set of people, and it's hard for normal humans to take advantage of. And then the great thing is that Douglas Engelbart and Xerox PARC brought us the mouse, which then moves us into an era of graphical user interface. This kind of dual hand interaction model of being able to use the mouse to do XY position changes on the screen, as well as keyboard, means that we can move from a binary precise input as well as a very fluid direct manipulation model. And so the mouse gave us this new degree of freedom to move along the X and Y axis, which allow us to have these really transformative applications like Mac Paint, Photoshop, as well as Excel and VisiCal. which is actually very meaningful because it changes the way that we interact with computers and understanding and manipulating data and information. So then the mobile era kind of came along. And I think a lot of people, when they think about the mobile era, they think about the multi-touch gesture, which has a huge role in the narrative of personal computers. But I think that there's also another dimension to it that we should consider, which is the hardware form factor. It's a lot smaller, it's very portable, as well as the fact that it has a very robust camera. It means that it gives your machine a sense of space through the GPS as well as sight in this kind of very portable format, which makes it super unique because it gives you kind of this immense power of like reaching deep into the machine to be able to manipulate where you are as well as what you see, and then be able to broadcast them very quickly. And so, Instagram, Google Maps, Uber, all of these things rely on the context that is provided through this new degrees of freedom. And lastly, now we're at this very baby stage of immersive computing. The amount of input that we need to synthesize and understand has expanded in quite significant amount. We kind of need to know the user's detail and context at a very granular level. For example, how tall are they? Like, what is the space around them like? Can we see the user's hand? Are they using both hands or are they using one hand? All of these questions are constantly being asked by the system, and the ambient as well as discrete user input signals are all intermixed so that we can try to calibrate what is the user's intent and then try to respond with the correct kind of system output that we're seeking for. So we started off with something that is relatively simple, like a key press, which is kind of like a 1 degrees of freedom where you can either go up or down. And then we kind of moved along kind of the trajectory on a similar format until we now have kind of the immersive computing where we have the touch controllers through Oculus, which is now commercially viable for people to use, where you can have positional as well as rotational tracking. And then now we're kind of moving on to the stage of being able to see your hand, which is very, very powerful, but also can be immensely terrifying for designers, because now you move from 1 degrees of freedom, which is a basic tap or basic key press, to 6 degrees of freedom, which is now where your hands are, and all the way to your hands, which you actually have 27 degrees of freedom, just on the kind of different combination that your fingers are be able to articulate. So imagine all these kinds of permutations that you have and how that have really expanded the ways humans can express their intent. And these are all the just basic intentional input that the users can create. And I'm not even counting in terms of like additional kind of ambient or environmental input that sensors might pick up. For example, like a room scan, or who's in the room with you, or how are you trying to generate social dynamics within your experience. So, as we kind of expand on the input that is being ingested, it's going to be really hard for the designers and the creatives who are manifesting these types of experiences to kind of direct and also to be able to accommodate a lot of their expectations. And I think that that's why kind of immersive computing and spatial computing have this tendency of feeling there's an uncanny valley, or the fact that it's very often to break immersion because things just don't react the way that you expect it to. And I think that this is an interesting place for designers to reconsider their role in how they're going to shape up this new medium, because designers can no longer just kind of hope to like funnel their users through a single path like we did in mobile devices, where you take one screen and then the next screen and the next screen. There's a lot of different permutations here. And for us to create a holistic experience, we are going to need to think about what ways can we generate that. So it brings me to the second point today, which is to kind of consider what are some of the basic Lego pieces that we're going to need to be able to accommodate the demands of our users' expectation. So the fact that users are giving up and disclosing to the system a lot of human context in terms of like where their room is like, where their body is like, and things like that, they are going to have an expectation where they would like to have highly customized and personal outcomes. So one of the cornerstones of being able to achieve that is to think about how can you make your asset creation process a lot more dynamic. In a way where it's like when you make an icon, it's not just one single PNG, but it can create a fragmentation or a branching tree of like different sets of icon that could be generated through the user's intent and through the user's input that can be contextualized correctly. So today I'm going to run you through a couple of examples and tool sets and research that has a kind of interesting implication on this kind of generative asset approach. So first thing first is this is an example of a very rudimentary kind of like in production methodology of how people create generative assets. So the first two is something that I built a while back, and it is leveraging a tool called Houdini that allows you to create a network that basically generates different types of procedural outcome. This was in particular that I tried out to build a proceduralized kind of room creation as well as layout creation. So you can see here on the far left-hand side is basically the logic structure slice, and then the middle section is kind of like the artifact of what is the output, where you can change different sets of parameters and kind of reallocate how the room is being laid out and distributed. And obviously Houdini is a very powerful tool, but I can see that in the trajectory of what's going to come in the next couple of years, a lot of tools is going to have to figure out ways to kind of extract semantics and logic out of the user's intent, and then be able to create kind of more abstract representation so that, you know, when you build a room, it's not just building the room one time and then hope that it will work across different physical environments when you're using AR experiences, but of the fact that it's going to customize and kind of morph based on what the room scan is. And then on the far right side is a very quick snippet of a procedural animation system where this lizard is basically being able to track an object and move around dynamically based on the landscape and the topology of the environment that they're in. And I think this is particularly important because a lot of the believability and the immersion that comes from spatial computing has to be that the characters as well as the things that can react to the real world needs to behave and exhibit similar kind of traits. And this is not something that you can bake in an animation and hope that it'll work in every different conditions. And so proceduralizing animation is super important. So these are some examples of cases where these are already in production that people use very actively to generate procedural outcomes. But the problem here is that a lot of these kinds of frameworks are built bespoke to an idea. It's generally not generalizable to accommodate too much. For example, the way that the lizard move only accommodates for a quadruped that has a particular trait. If you change it over to a bunny, that is not going to work. And so I think that this is a really good starting point for us. And moving on, I'm going to talk a little bit more about research side of things. So here is an example of a paper that was being done by the Harvard Graduate School of Design, which is around how can we start to proceduralize room layouts. And this particular paper is particularly interesting is because it focuses a lot on actual real life architecture. So they have a lot of constraint that is built into it that they can talk to the system. And they basically run it through a GAN kind of algorithm that allows it to generate and morph the different kind of like ideal layouts based on the parameter that's given to it in a way that it can present the architect a lot more different ways to kind of understand and digest some of the design decisions they have based on different constraints. And I think that this particular strategy is also going to be very useful for spatial kind of experiences because it offers the designers and the engineers a way to kind of evaluate whether the experience that they've created could work in different room scan environments as well. And then when I talked about animation, one of the really interesting things is that procedural animation is very costly to set up. And I think there's more interesting ways to tackle this. So this is a paper that is being done by UC Berkeley. Some of the research there were using very basic kind of 2D standard iPhone captured videos as a way to generate kind of animation data through pose estimation. So they're basically able to automatically kind of rig up a character and then kind of review how it can be adopted in the 3D scenarios. And you can see here at the bottom is that this character is not only doing backflip based on the video footage, but of the fact that this character is capable of moving along different kind of landscapes, like different curvatures. He'll still be able to land correctly. And this is going to be super important when we have the ability of reviewing the experience through headsets in different kind of like room contexts. And this is going to be super powerful of giving characters as well as entities inside of the experience a very sense of dynamic and contextual way of expressing kind of certain animations or feedback that they need to give to the users. And lastly, this snippet of research is something that, one of my colleagues, Jun Saito, and someone that I work with right now on kind of like more proceduralized animation that is driven by kind of understanding geometry semantics as well as kind of functional semantics. So it's basically being able to detect things that exist within the room and be able to cue the kind of movements appropriate to that spatial context and the geometry appropriately. Historically, the way that it's being done is basically kind of like you have a game engine, you have a state machine, and you put in some really rudimentary rule with baked animation and hope that it kind of gets into the right place. But we definitely have seen incidences where it's like, for example, in video games where, a character's hand might just intrude into a geometry that doesn't really make sense, and that breaks immersion. This system basically removes that constraint. And the great thing about this is what I call the chair of torture, where we basically test how robust this algorithm works in terms of like under different circumstances. So if we give them different chairs, whether it's a digital chair or a real chair in a room scan, how would the character be able to dynamically adjust its body gestures and things like that appropriately? And in particular, you can see here that it's like trying to navigate and pick up objects, or it's trying to deal with different shapes and sizes of environment that it has to climb through. All of that is basically dynamically generating an animation framework in a neural state machine to be able to control and kind of like tap into a very natural way of animation. So all of this is super important. And I think that it's important to recognize the fact that, it's going to be extremely powerful for creatives to be able to access these ways of generatively kind of intersecting with creating assets that could be leveraged in different contexts. And I think that this brings me to the third point, which is like, now it's great. Like now we have different ways to generate these like highly variant and highly customizable assets. What does that mean in terms of finding the right one at the right time? And this is the third point that I want to talk about, which is the curse of dimensionality. Is to kind of consider, this is a particular term, a particular problem that, like a lot of people who deal with machine learning as well as artificial intelligence and large data set kind of have to deal with, which is that when you have an expanded amount of parameters dealing with the data set, you have the struggle of actually not being able to efficiently find the right kind of solution as you navigate through all the different possibilities. And so the question here is like, what does this mean for design? So, if we look at the simple concept of scrolling, we have the starting point of kind of like being able to scroll up and down. So there's like this one directional axis, and then now you have your phone, which then is like multi-gestural, and you can move things left and right, which is great. And then you have the VR component, which is being able to see things in space, being able to feel where your body is, as well as, in the context of kind of AR, like highly specialized, highly customized, and highly personal space where the AR experience will have to sit in, as well as kind of additional social implications. And so the challenge ahead for all of the designers right now is the fact that, the value that we provide is no longer about placing guardrails for users where we go from point A to point B to point C. And instead, creatives in spatial mediums are demanded to provide more generative solutions so that users can basically direct within a possibility space that is constantly shifting, because we have no control over the physical context and the size and the shapes of different users. So if we look in the past, traditional 2D surfaces, X and Y, creates a two-dimensional possibility space. it's something that's really easy for us to imagine. It's kind of like an X and a Y graph. But as we introduce more parameters, for example, now you can do gestures. Now you can understand proprioceptions. Now you have to think about what is the playable or like experience area, as well as like thinking about social dynamics, how they come into place. All of these kinds of parameters have an ideal range or an ideal value. And trying to navigate through that within the system is going to make it nth dimensional possibility space, which is going to take quite some time to traverse through. So I think the question here is for us to consider as designers is how can we help the users to navigate and search through possibility space for the most optimal solutions? I think fundamentally for designers is that we are basically the bridge between the new technology as well as how the humans is capable of understanding the power and the way to use the technology itself. So if our possibility space and the different options that the users have grow exponentially as we increase the amount of parameters that we ingest, then it becomes really tricky, because what happens is that the good solutions will start to shrink as you kind of add more constraints and parameters to calibrate what should be a desirable outcome. And then at the same time is that the kind of good solution will start to move further and further away from each other, and it will become more sparse and kind of filled up with kind of really big areas and chunks where they're just bad. They're just purely not desirable for the users. And so it's going to be something that I think it's going to require kind of the end users to be able to tell the system and continue to correct course as it navigates through this kind of possibility space to figure out like how can we display the best outcome for you. And finding this good one is definitely not trivial. And I think that this is something that like my team from the design team has been actively working on, is to try to understand what are some of the user experience and controls that are required to generate this type of experience. And the problem here is the fact that, and the most important thing here is that a lot of these kinds of experience is about doing this in real time. And so that's something that we should consider. And I hope that this leaves you with a little bit more questions and think about the type of work that we're doing and thinking about moving ahead, what kind of role will design play? So thank you very much. And I really enjoyed the time speaking with you guys. Thanks.
Thank you, Agatha. Welcome.
Thanks so much for having me.
Yes, it was super interesting what you were exposing, and I think it's the next frontier, because we already have a lot of research going on the visualization hardware, optics, and everything. But what you were dealing with are the biggest design challenges, because the size of the design challenge for immersive experiences is huge, and having some aid would definitely help in creating better experience. And by the way, reality is somehow procedural.
Yeah, exactly. Yeah.
So, is there something that you would like to add after the presentation for our audience?
Yeah, I feel like that actually, just as a general thought, in terms of having to deal with these tools and actually dealing with some of these problems in both production as well as both design work, I feel like that designers are kind of in a position where we kind of have to shift our mindset quite a bit in terms of from the traditional step-by-step UX kind of approach, to maybe actually learning some of the new tools to kind of expand the way we think, because obviously the tools that we use shapes the way that we think about things. And I think that if we can start learning some of the more proceduralized tools, it gives you a different window of kind of finding design solutions. And I think that's kind of a really good starting point to just kind of dip your toe into it. And then eventually, the interest of VR and AR and all the immersive medium is going to merge with proceduralism. And I think that will put us in a good position of being able to author more interesting experiences in general.
Yes, of course, and we are about to have tools and devices for immersive experiences that will need to have a perception themselves. So to anticipate what we do and to adapt the content and the experience to the context in which this is taking place, and to save all the good ideas from being distracted or damaged by the context. They have to adapt by design to it. And
I think that a lot of it is just like, we have the expectation that nowadays devices can absorb a lot more input from the environment and from the users. Like every single generations of technological leap, I feel like we're getting better and better and building better sensors, like where we are, like what are we talking about and things like that. And now is actually the designer's job to kind of put all those kinds of input together and kind of combine them in a way that's meaningful for people. And that part is really hard because there's so many different variations and possibilities that you could have based on those sensors input. And because as they become wider, it's just going to be harder to distill like what the users actually want. And I think that requires a lot of practice. And I feel like right now is a good time to get started and like figure out like, what is going to be meaningful.
And do you have any there's a question for you. Do you have any resources for designers to get started? You were mentioning Houdini, that I think it's one of the main tools to get into the procedural generation topic.
Yeah, I think that like Houdini is a really, really good starting point. Actually, some of the 3D tools also still offer some basic proceduralism that you could do. Like with Cinema 4D or Blender, they have modifier stacks that allows you to build procedural mesh generation. That might be a really good starting point as well. I personally really like Unreal Engine's blueprint approach. A lot of people have been able to make dynamic props and layouts based on blueprints, because like you basically have to sketch out a curve, and then the props that you've designed can basically lay out dynamically within the scene using that blueprint mechanism. I think that helps a lot as well. And I think from Adobe side, we're also investing a lot on proceduralism because of like a Substance that we recently acquired. So a lot of the material and servicing technology that we're doing to create like different visual effects could be done in Substance as well. It's a very impactful tool, I feel like.
Yes, of course. And you also have Mixamo, so we expect to see some implementations of the cool procedural things that you were showing in the next
and I think the
generation.
future is where I feel like the really exciting part for me is that once designers have the capability of creating procedural assets themselves, then like we can start to consider how can we morph and change parameters in runtime so that it fits within different contexts and scenario. And that's the part that I'm like very, very excited and look forward to getting to, especially like some of the procedural animation stuff as well, which is hard to do, but I feel like we're going to get there.
Thank you. I think this was the last question for you. We are almost out of time. We just have a question from Rui Jiewang. With different parameters, different outcomes. A lot of the resources mentioned are for 3D. What about language, voice-led experiences? That's quite interesting. Yes.
Yeah, I think for voice, there's a lot of kind of interesting resources. I think that field is becoming more mature because of all the voice assistant. One of the resources that you can look into is Dialogflow. It's a library developed by Google, which works with TensorFlow, that allows people to use kind of NLP to kind of drive some of the conversational feedback loop that you want to generate through conversational inputs. I think that a lot of that still have to work in tandem because with 3D related things, mostly because I think we're multi-sensory creatures, and the expectation with immersive medium is that you want to have both audio as well as visual experiences, and I think that both of them go hand in hand as well.
Thank you again, Agatha. So thank you for presentation, and we hope to see big things from Adobe.
Thanks.